How many of you are ready to hear about the monster model? Ooh, so many of you, great. Then I must introduce to you also my co-founder and the CTO of Upright, Juho Ojala.
Good afternoon.
So he's joined me here on the stage because we would like to give you an overview of how the model works and what the approach exactly is. We try to do this as a mix of enough detail but not too much detail. Hopefully we will succeed in that and in leading you into this content. So basically, as a child, I was not a very light-hearted, careless child. I think I'm not a light-hearted, careless woman. So this is really the problem statement that I wrote for myself at some point. That what is the problem? What needs to be solved? And it was that it's long, it's not sexy, it's not like a startup should have a two-word catchline. But this is really the problem that I want to solve, which is that I don't think we, as humanity, very well understand how we should be allocating our resources, be it human resources, natural resources, capital, whatever we are talking about, in the global 21st century capitalistic system, in order to really do our best to maximize the likelihood that the great work that we've been building for our species over the last decades and centuries and millennia, we would continue this progress of building a thriving humanity. And of course, the planet cannot be ignored. We are dependent on it, and we should treat it accordingly. Okay, so that was the problem. What is then the solution? As you can see, I'm a really bad case of a hardcore engineer, because this is the only way I can really think. It is to build a top-down model that allocates basically all the values that company creates or the impacts that it has. There's a bit of a terminology difference, and depending on a situation, which one we prefer to use, caused by the private sector globally. Attribute these to real companies. What do I mean with top-down? This might be one of the most important things to understand about our approach. The most traditional approach that we have been taking in the past couple of decades to the impact of companies has been a bottom-up type of approach, which works in many cases very well. Probably the best known example of a bottom-up analysis type is lifecycle analysis. I know there's probably a lot of people in this audience today who are familiar and have been doing lifecycle analysis, LCAs, for quite some time. That's a great example of where we look at one individual point, for example, one product, and try to really understand in detail everything that has to do with its life cycle and all the impacts that have to do with it. This is a very relevant and useful approach for many cases. However, the problem we're trying to solve, as probably all of you understand, that is just simply not enough. We need to find a way to actually, first in a very dirty, inaccurate way, to start to allocate all the impacts globally to real companies, to understand that every point is calculated once and only once, and that we actually get something that sums up to a reality. So for example, that all the GHG emissions of companies sum up to a global total, that is the total of all GHG emissions produced by the private sector. This is quite a big challenge. When I started this project, many of my great people that I talked to in academia or business recommended that we would start by doing one company or one industry or something like that. That is simply not the minimum viable product in this case. The minimum viable product is a very imperfect, very inaccurate model that covers the whole space. Okay, but that's the solution. So basically the task we have given ourselves, maybe you can join me here so that we are not blocking the screens. The task that we have given ourselves is to build a model of, shortly, net value creation of companies. And of course, we have put in a subtask, and we think this subtask, this division into 4 subtasks, might be actually the best way for you to get an understanding of what concretely we are doing, and also might give you an idea of how this actually relates to you and your company and your investments, to understand what kind of aspects are we looking at. I'm going to walk you through the first 2 easy ones, and then I'm going to hand over to Juho for number 3 and 4. And he's also going to show you a little bit of the real data in the model so that you get the idea of how it looks like in practice. Well, I said this is an easy one, but actually this is probably one of the most laborious ones of the whole process. First task, we have to define what we mean with products. So what is this space actually consisting of? So one of the, probably the things that we have in terms of just pure manual labor in the past 2.5 years, and one of the biggest risks that we've been taking, is that we've built a network consisting of all products and services that can be traded in the global markets. Mathematically speaking, it's not a network, it's actually a graph. And it entails in it consists of all the, not just the nodes themselves, but the relationships between those nodes. And to make this a little bit more concrete, I'm gonna give you one example. This is now one simple example of a product that lives in this huge graph. Let's look at the product apple, the fruit, not the company. So this is so nice and beautiful so far. So Apple lives in upright product graph. It needs to know what we call generalizations, more general versions of the product. We can also call them parents, because we like to see this kind of as product families, but these are quite mixed families, and you might have quite many parents and children and siblings and so on. So they're very modern families. The first parent in this case for Apple is pome fruits and stone fruits, whose parent is fruits, whose parent we're now losing, no longer on the slide, but is plant-based products, and so on, all the way to the core of where all the products come from, the core of the whole family. And of course, as logical people, you might have guessed, there's also the other side, which is then children. So more special versions, or specialized versions of an apple. In this example, there's a simplified example of just green and red and yellow apples because of lack of space, but maybe more realistic, these might be different breeds, or what do you call, like different types of apples that you can buy and sell in the global markets. Okay, hopefully everyone is following us so far. Then we have a very important thing about value chains. So it is very crucial in the upright model to consider the whole value chain, not just the internal impacts. So as a company, you shouldn't just be interested, or your net impact does not consist of only the, for example, emissions that come out of your own factories, but rather you are part of a global value chain. And why is that so? For example, this is now Mikko's laptop here, produced by Apple on this stand here. It is not fair that Apple only gets it is not actually accurate. It is not true that Apple is only sort of liable for the impacts of putting together in a nice, neat little factory this beautifully designed little piece of technological gadgetry, and basically not having anything to do with the bad mining industry where all the emissions come from. Obviously, this laptop would not exist if it weren't for the mining industry. So Apple should get a teeny tiny slice of, well, not just the mining industry, but more specifically different parts of the, for example, the aluminum industry globally, because otherwise these products would not exist. And vice versa, the mining company would not have an incentive to exist if it weren't for zillions of companies like Apple who use their products at some point of the value chain. This is now a simplified example of some pesticides and an incomplete example, apple tree fertilizer and tractors, something you might need if your product is an apple. Let's say that you are now an apple farmer company. And then, of course, as you might have guessed, the other part is then downstream. So in addition to upstream, you need to understand downstream. Who is using your product next? Or if it's a B2C product, a consumer product, the activity of actually using the product, in this case, eating an apple. So in this case, the apple might go to a delicious apple pie. So the next product who would be downstream from the apple would be an apple pie sold in a bakery, for example, or wholesale of fruits might be also another product where this is feeding into. Again, this is a simplified example. In reality, as you understand, there are quite many products that the apple feeds into, but just to give you some examples. And this is a very important part. Since we are really digging into, and what we are trying to do is dig into the wisdom that humanity has been building in the past decades and centuries and millennia, really, we are trying to codify, first of all, read, and Juho will tell a little bit more about that, but automatically read and codify massive amounts of human-made knowledge. And that knowledge is mostly being codified in the format of natural language. So that's why we need to also, for every one of these nodes, we need to give them phrases so that computers can understand what they mean. So basically, this is now, again, a quite simple example of just two phrases. Maybe we have the word apple. We have these concrete strings here. Another would be the Latin name for apple, so Malus domestica. In reality, there's quite many of them. In this simple case of an apple, it's pretty clear. If you talk about a bit more sort of a specialized product, like let's say a cybersecurity mobile service aiming to do X, Y, Z, then as you can understand, there's a lot of words that come from the business world, academic jargon, scientific jargon, and so on that need to be included in order for this to find the right information. So we also phrase each and every one of these nodes. Okay, this is now the main idea of the defining the products part. This has entailed a lot of manual work, but also, of course, a lot of ways to build and teach and train this graph of products with many tricks we can do with our friends' computers. The second one really is simple, at least compared to everything else. So that is just simply a grid through which we start to look at impact. So we try to understand what are all the different ways a company can impact the world around them. We did one quick and dirty version, iterated quite a bit with some experts, some professors, academics, our investor users, our company users, and so on, and landed on something like this, which is now at use. If you have been visiting our website, you're probably very familiar with this. So shortly, we look at 4 dimensions of value creation. We look at the environment, of course, the health of people, both the physical and mental health, society at large, so also including the economy, such as taxes and jobs, and knowledge. The 3 first ones are most likely very familiar to all of you from many frameworks regarding impact these days. The 4th one was something we couldn't find in any of the other global frameworks, but felt that intellectually, honestly, we cannot depict a company's net value creation if we don't take into account what kind of knowledge it has created or it is creating and or distributing, or what kind of infrastructure it is creating for distributing and creating knowledge. And then there's, of course, also the resource side. So when we use the brains of highly educated, passionate recent graduates from Aalto, we are also using a human resource that is valuable as well. In addition to these 19 impacts, we look at 3 parts of value chain, as just explained. So in case there are other people who like to see this as a matrix, a sort of nerdy mind, so we can understand it consisting of 19 impacts times 2 valences, so pluses and minuses, times 4 parts of the value chain. So we form like a 114-point matrix that we start to fill in for all of the products and the services in input number 1. Okay, is everybody following me up until now? Great, because now I'm going to give the stage to Mr. Juho Ojala, who is going to do his best to explain what happens next in our task division.
Yeah, okay. So the next step would be, of course, filling out that matrix that Annu was talking about. So what our task now is for each impact attribute 100% of that, and exactly 100% to each node in the network that Annu was talking about. And in the network, of course, each node is a product, or more generally, a product or a service. So this step is about attribution of impact to products. And this step can be divided again into 2 subtasks, with the first one being collecting and quantification of knowledge that exists of the impact of individual products. And the second subtask is to allocate that impact along value chains. So for the first question, or the first subtask, the question that it answers would be, what is known about the impact of individual products? And for the second subtask, the question would be, to what extent are individual products responsible for their own impacts and the impacts of other products? So for the latter, you might, for example, concretely ask, to what extent is an apple producer responsible for the impacts related to fertilizers? Or again, the other way around, to what extent is a fertilizer producer responsible for possible positive impacts that apples produce, for example, in the health impact category? So for the first question, what is known about the impact of individual products? There are 2 steps to solving that in our particular solution. First step is searching and classifying scientific articles that discuss that particular impact. So basically, this way we find out what science is saying about the impact of that individual product. Very importantly, there's another step, which is to generalize that knowledge within product families in a manner that Annu was discussing earlier, based on this specialization and generalization concept. And for the second part, there are 3 steps. One is first to estimate the market sizes of all products and services. Second step is to model the value flows along value chains, meaning how much value is flowing along the links in the product graph when the links are value chain related links. So what is kind of flowing along those value chains and how much of value. And then based on this information about the value flows and the information that we have previously acquired about the impact of individual products, we finally attribute or allocate that impact to all the products and services. And okay, and that's it. It's done. I unfortunately don't have enough time to go into all of these details on how all of these boxes work, but just to give you an idea of the general approach that we are using for this, I'd like to quickly talk about the one that is highlighted, the search and classification of scientific articles. And it works like this. So again, here are 2 parts. One is to search articles that might be relevant, and then for those that we have found, determine whether they actually are relevant and what kind of causal relation they may be stating. So how this works is that, as Annu already mentioned, each product in our product graph has these terms that describe it. For example, in case of the product label tobacco products, the term would be tobacco. Similarly, for the impacts or the impact labels, we have words that describe them as well. So for example, in the diseases impact category, there would be a phrase like cancer. And then when what we do is that we take all the phrases that describe products and all the phrases that describe impacts and all the possible combinations that you can create out of them and search for articles in a database of scientific articles. We are currently using a core called database with around 135 million articles. We are also recently introduced reading Wikipedia as well along that. So in case of the phrases cancer and tobacco, we might find now, in this example, there is an article that we have found, and the job of the classifier is then to determine whether this is relevant and what kind of causal relation we might have there. So the job of the classifier is basically to say that, okay, in this case, is now tobacco causing cancer maybe? Does the article say that? Or is it maybe helping treat cancer? Or did these terms just happen to appear in an article without the article stating any causal relation between the product and the impact? So that's the job of the classifier. Our classifier, technically, it is based on a technology released about a year ago from Google Research called BERT. It is this kind of a neural network which has been pre-trained by making it read Wikipedia, basically to first learn how the English language works. And we have taken that and then trained it by our manually labeled batch of 35,000 scientific articles to make this classification task. So in order to accomplish this, we have done this job of manually classifying 35,000 scientific articles so that we can use that to train the neural network to do the job for the rest 100 million. Yeah, we are kind of crazy. Okay, So that's how so this is the approach that we use to answer the question of how, what does science say about the impact of individual products. Right, okay. So the next step we have already done, the third step. The next step is conceptually more simple. Here we just map individual companies to products, preferably weighting by revenue, and then use that information on the products of the companies to calculate their impact. So when we are calculating their impact based on their products, we are really calculating it based on what those companies do and not on those how factors. So that's it. It's basically done. I guess you might be curious what we then get out of there. Okay, now everyone can see it. So this would be McDonald's. And there you can see, if I make it a little bit larger, you can see better. You can see some products that we have mapped for McDonald's. And here is now the impact profile for McDonald's. Now I need to be really it's a little bit hard because I don't see it on this screen, but oh, yeah. I'm sure you can follow. I'll be sitting here. Okay, so I can open this up. I can see that here in this environment category, the most important impact is waste. In the health category, the most important impact happens to be related to diet. In the society category, the most important impact is the positive jobs impact. And now what we can do is look here to see what kind of products are driving this impact. So what you're seeing here is that the sugar-sweetened soft drinks are currently driving this impact according to, of course, what the scientific articles say. If I'm really nerdy, I can click here and see even examples of those articles that contributed to the result. In this case, if I'm even more geeky, I can enter expert mode and see some of the predictions that we have from the classifier that I was describing to you earlier. This is actually something that we only have internally. Most of the other things that I have shown are also available for others to use. So this is an individual company. Of course, investors typically don't look that much as individual companies, as more into groups of companies. So let's take a look at a group of companies. Let's take, for example, Fortune 500, maybe some German companies, and Lauri's here, so maybe Nasdaq, Helsinki at least, we have that. Okay, congratulations, Lauri. Seems to be the best score. Okay, so now if I were an investor and I might have investments in some fund that is tied to a benchmark that is using some kind of some index that is related to Fortune 500, I might be curious to see a little bit more into Fortune 500. So let's look at that. Here's Fortune 500. On the top level, there is quite large impacts on the environmental side and the negative side. In health, there's both positive and negative stuff, and also significant impacts in society and knowledge plus side. And again, of course, I can see what kind of companies are driving these impacts. I click here, look at societal infrastructure. We see there is the waste management company, it contributed most. There's also some insurance companies and so on. On the health side, I can look, for example, at diet. Not very surprising, we have PepsiCo and McDonald's and Coca-Cola, but okay, number 4 is Alphabet, Google's parent company. I wonder why that is. Let's see. Okay, so it's related to their advertising products, which has been shown to have this kind of negative body image impacts. One more thing I would like to show you, which is very important, and it's related to values. So as Annu mentioned, we are not in the business of dividing companies into good and bad ones. What you're rather trying to do is to create tools that allow people to act on their values. So to facilitate that, we have this concept of value sets. So when looking at, for example, this set of companies, I can use value sets to look how the companies in this group perform when I assume a different set of optimization criteria, or basically value sets. So here's an example. Let's take, for example, one that thinks that knowledge is really important. It takes a few seconds, and here we go. So now we have this kind of different list. This table is sorted based on the net score, which takes everything together. So actually, cybersecurity company happens to be very high on this knowledge category. There's also Adobe and Cisco and HP and Microsoft and so on. So, okay, if I would care about knowledge, I might want to invest in these companies a little bit more. If I would care about health, I might want to invest in company Celgene. I don't know what it is, but probably it's good. We could check it out. Okay, they make this kind of biotechnology stuff. Yeah, they make cancer drugs, basically. Okay, great. So there are many ways to use these value sets. For example, asset managers use it to create portfolios or create funds or other investment products that are optimized according a specific set of values. So they can, for example, market it to the customers that care about those specific values. But it's always important to define your values, because if you don't do that, then someone else will. Is there, Annu, still something you would like to add?
No, I think that was a great wrap up for that session. So hopefully we were able to give you a bit of an understanding of how the model concretely works. As many of you know, there's a free version also on our website if you want to just understand how the data works. And obviously you will all be more familiarized with it when you see your own data throughout the project through this methodology. But
you can also create your own indexes of companies that you...
True, very good point. So many of our users are also using it to create their own basically indexes or groups or and also comparing to the indexes that they are following. And also, obviously, this is the use cases for the data also have to do with forming new products. So not just reporting and seeing how your investments are doing and improving your existing funds, but also giving the model optimization criteria, giving it a space where you want the investment targets to be picked from, and let the model do it for you. This might be a big thing when more and more passive investment products are becoming a big thing. But more about that later throughout the spring. Thank you now for this.